Hi, in this video we will be looking at merge sort algorithm. So merge sort uses well-known divide and conquer approach to sort the input, and the other divide and conquer algorithms is quicksort, and basically merge sort uses recursion to solve the problem. And here you can see an example of a recursion. So I'm pretty sure that you're familiar with this concept from functional programming. So this is the visual illustration of merge sort. This is one thing. We will do the same thing on a different input on paper, and also we will look at the Python implementation of merge sort. I guess that's all. That's going to be all for this video. Yes, so the calling algorithm consists of these three structograms, which is a merge sort, which takes an array, and it creates a copy of this input array, and it will use B to sort A, and it will basically call MS, and MS is the following, and MS inside of it will call merge, and merge is here. And I have exactly the same code in Python, and in a moment we will take a look. Yeah, you can read more about the complexity of merge sort here. So the essence of the approach is that the merge sort kind of divides the bigger problem into sub-problems, and in this way it comes to the answer. And one more thing is that we will need to divide the array into smaller subarrays, and in case when the length of the input is odd, then the second part of the array will be bigger by 1 than the first part. But if the array consists of even number of elements, then both parts will be equal. Okay, so this is the merge sort implementation. You can just ignore this prints, and I will also share with the link to this Replit repository just for you to see. And here is the example input, which is fairly small, but that's not the point. So here the length of the array is an even number, 6, so that's why we will divide it into equal subarrays. So the first is the idea is to have a separate individual elements of this array. So we will go and continue dividing until we reach that every element is a separate element. So we will need to get these single elements in the end. Okay, so we first here we have some notations like U, V, and M, and basically you can refer to U as the left part of the index, like leftmost element, and V is the rightmost element, and M is the middle. And in the implementation, I think I used LMR, which stand for left, middle, right, just for more descriptive way of implementation. So in the very beginning, it's U is equal to 0 and V is equal to 6. So 0 plus 6 divided by 2 equals 3. And one notation is that we need to choose the floor when we divide. Okay, so it's 3, so 1, 0, 1, 2, and 3. So here we need to divide. And indexing is that U should be inclusive and V should be exclusive. As you can see here, U is inclusive, V is exclusive. That's why we will divide it here, and we gain this array and this array, which consists of only one element. So this one does not need to be divided further because we already reached the single element. But however, we need to separate this. Okay, my bad. So we will, as I said earlier, when we have odd number of elements, then the second part of the array is going to be bigger by 1 than the first part. So when we have this 3-element subarray and we divide it, then we basically get a single element from on the left side and 2 elements on the right side. And we need to further divide this 3, 2, and we divide them into single elements. And when we have this individual elements, then we can start merging. And the first step of merging will happen here in this level. We merge them together, and then we need to merge these 3 together. And we merge them here, and we continue with the right part of it. However, I want to mention that the steps of the computation might be different in any code, but here, just for the simplicity, I'm going this way. Basically, first merging will be here, second will be here, third will be here, fourth is here, and this is the last merging process in the Python code. And so the idea is the same, that we need to divide them and then merge them in a sorted manner. And we have this small sorted subarrays that needs to be further merged and in a sorted way as well. And that's how we reach the end of the algorithm.